So looking at types of computer files. Types of computer files, and that is called file processing. Now, a computer uses so many different files. Okay, so many files, but those files are categorized into the following types. We have the files referred to as serial files. We have the files referred to as sequential files. Sequential files. We have files referred to as index sequential files. You've been using them, but you didn't know what they are. Then last, we have what called random files. Random files. Those are the types of files that computers use. The files can either be sequential, they can be serial, they can be index sequential, or they can be random. But in your syllabus, you're going to be basically looking at the three: serial, sequential, and random. Actually, even sequential, they may not bother about it so much. But it will be good to talk about it to make you understand properly how the rest work, because it will be like a comparison. Now, let's begin from serial files. Now, first of all, why are they different? All these types of files are different because the way we add information in them is different. The way information is organized in them is different. The way we delete values in them is different. And the way we access or search for values in them is different. That's why these types of files are different. So the way we insert a value in a serial file is different from how we insert it in a sequential file, index sequential, and random. The way we search for a value from a serial file is different from the way we search it from a sequential file, index sequential, and a random file. The way we delete a value from a sequential file is different from the rest. That's why these types of files are different, because they operate differently. They operate differently. So now let's first look at how serial files work. I'm going to use one example for all of them so that you can understand how they work differently. So at first, we're going to look at serial files, and we're going to take an example. We're going to say, illustrate how the following values can be inserted and arranged in a serial file. Show how values 10, 5, 6 can be input and arranged in a serial file. Now, for a serial file, it is the simplest file. Why? These are these values will be input. Okay? 10 is coming first to be put into the file. So assuming this is our serial file here. At first, we are having 10 joining the file. 10 will be put in position 1 here, in the first position. These are positions. Second position and what? And third. These are what? Positions. So 10 will be put in the first position. Why? Because it has arrived first. Then when 5 arrives, 5 will be put in the second position. Why? Because 5 has arrived second. Then 6 will be put in the third position. Why? Because 6 has arrived third. We'll put it there. That's how those values will be kept in a serial file. What is the order? In a serial file, the values are inserted in the order in which they join the file, or in the order in which they are added to the file. So the first value to enter the file will be put in the first position. The second value to enter the file will be put in the second position. The third value to enter the file will be put in the third position, even the fourth, until so on. So how do we define that? In a serial file, values are kept in the order in which they are added to the file. And that is called a chronological what? Chronological order. Chronological order. What does that mean? That there's no specific order how values should be arranged in a serial file. There is no specified order. The way they join is how they are put in the file. Very good. Now, how does a computer search for values in a serial file? How does it search for values in a serial file? For example, let's assume we want to search for 5 from this serial file. What the computer will do with the serial file, if it's searching for values, it will just go position by position, beginning from the first position, as it checks whether the value it wants is the value which is not positioned is the value that it wants. So if it's looking for 5, it will begin from the start of the file, which is position 1, which is what? Which is position 1. So here, it will check if the value in position 1 is 5, and this is 10. Then it will realize that 10 is what? Is not the value. Then it moves to the next position and search if this is the value. And in this case, if it's looking for 5, it will basically reach 5 in the second position. So when values are being searched from a serial file, the computer will search each value one after another from the beginning or from the first value until when it reaches the value that is needed, or until when it reaches the end of the file and the value is not there. Now that process of searching for a value from the starting from the first value until you search each value one by one is referred to as the serial access method or the serial search method. The serial search method. And sometimes referred to as a serial access method. That's how values will be searched for from a serial file. The computer will search one value after another. So if you understood very well programming, it means that in this case, you'll have a loop from the beginning until the end as you compare the values in each position. Now, how are values deleted from a serial file? How are values deleted from a serial file? In order to delete a value from a serial file, the following steps are performed. For example, let's assume we want to delete 6 from this serial file. At first, the computer will use the serial search method to find 6. What does that mean? It will search all the values from the beginning to find the position where 6 is. And 6 is there. Now, if it finds 6 here, it will not delete 6 like this. No, it won't do that. Here, what happens here is this. If it finds the value it wants to delete, a new file will be created. A new file will be created. After the new file is created, the computer will copy all the values which don't need to be deleted and copy them or transfer them to the new file. So which means now here it will put 10, this is now the new file. This is now the new file, and this is the old one, the old file. So now it will copy 10 here, copy 5 here, and it will leave out 6. That is what it will do. So alternatively, you could say, if you want to delete a value from a serial file, the computer will create a new file, then it will compare each value to the value being what looked for, and transfer the values into the new file, beginning from the first one, the first value. If it reaches the value which needs to be deleted, it will ignore that value. It won't transfer it in the new file or to the new file. After transferring to the new file, this file will be deleted or discarded or ignored. That is how values are searched. That's how we delete values from a serial file. The computer creates a new file, then it copies all the values to the new file, but it leaves out the value that does not need to, the value that has to be deleted. And that value won't be copied to the new file. The old file is deleted or discarded or ignored. Then the new file is what will be the file to use from that moment. That's how values are deleted from a serial file. Alternatively, you could say the computer will search for the value using the serial search method, and then after finding the value to copy all the rest, and then it will not copy that value to the new file. That's how we search for values from a serial file. Sorry, that's how we delete for values from a serial file. Now, how are values updated or changed? How are values updated or changed? If you have values in a serial file, how do you update them or change them? So we are going to assume, right, currently, we are going to assume we have our first file. Assuming we have our first file and we want to update a value there. It's our first file. So here we had which values were there? 10, 5, and 6. So assuming we want to update or change this value to become 10, what the computer will do will be very simple. It will create a new file here. After creating a new file, this is how the new file has been created. Then to copy the values, beginning from the first value, it will transfer them to the new file. Then when it reaches the value that needs to be updated, it will update that value and put it in the new file. So here, if you want, for example, change 6 to become 11, then here we shall copy 11. Or you could say it will transfer all the values to the new file. When it reaches the value that needs to be updated, it will copy the new value to the new file, but then discard the old file with the first value. That also can work out. Whatever way you want, as long as it's doing what we want, you can describe your own steps. You get? Because programming can be done in different ways. So that's how we update values in a serial file. Now, what if we have these same values and want to put them in a sequential file? I'll only talk about a sequential file and the random file. I will not talk about index sequential because it was removed from the syllabus. So here, let's see, what if you want to add these values in a sequential file, the same values, 10, 5, and 6, but want to add them in a sequential file. In a sequential file. How do we do that? If one that those values in a sequential. All right, now a sequential file comes from the word sequence. A sequential file comes from the word sequence. Now, in this file, values must be organized. That's why you're talking about the word sequence here. In a sequential, values must be organized in a certain what? Order. So a sequential file is a file that keeps values that are sorted or arranged in a specific order. The order must be logical. For example, ascending order, descending order, or order by birth, order by, I don't know, date, sorry, order, so many things. As long as there's a logical order, that's how sequential files keep values. So in this case here, these values we want to add are not in a logical order, but in the exam, they will specify the order that they want. They will say, for example, in ascending order. Ascending is, I don't know, just a spelling. Ascending order. It is like that. In ascending order, which means from small to largest. So in this case here, it will be the file. So I want you to pay attention here. Now, this is our file. And we want to add those values. They must be in ascending order. So 10 will be the first value to be added at first, which will be in position 1. Then in position 2, we need to put 5, but 5 won't maintain the order. So we can't put 5 in position 2. Why? Because 5 must come before 10. So what will the computer do in this case? The file already has 10, but now I want to add a new value. Whenever a new value is going to be added, what the computer will do is this: it will create a new file, an extra file. It will create a new file. After creating a new file, it will compare the new value with all the values which are in the old file, starting from the first one. So it will compare each of the new value to all these values that are already in the file. So here we only have 10 and we want to add 5. So it will compare 10 and 5 to see whether 10 is greater than 5 or to see 5 is less than 10. Now, since here 5 is less than 10, automatically it won't waste time checking other position. What it will do, it will now copy 5 to the new file and 10, but it will put 5 in the first position, or it will put 5 to be before 10. That's what it will do. So whenever there's a new value coming, it will compare it with all the old values which are existing in the file. And then to copy all the old values plus the new file, and then the new value, but with the new value in its correct position. That is what it will do. Another item is 6. 6 is trying to join this file. Now when 6 comes, now this time our file is obvious. This one here will be discarded because we got the new file. So now our new file we are going to use is, or the new file the computer is using is this one. So to add 6 to this file, the computer will compare 6 to all these values in this file, beginning from the first one. So it will check if 6 is less than 5 and 6 is not less than 5. So it will move on to compare 6 and 10 and realize now 6 is what? Actually here, after comparing 6 and 5 and realize that 6 is not less than 5, what it will do, it will just basically create a new file here and transfer 5 quickly in its position. And when it comes to 10 here, it will compare 6 to 10, and 6 is less than 10. So what it will do, it will copy 6 this position and 10 there. So for you can explain in your own way, the way you understand, you get. However, the procedure is that the new value must be compared to the rest of the values in the old file. Then a new file will be created, and then the new value and the old values will be put in the new file, but with the new value placed in the correct position. That is how we put values in the sequential file. Why? Because for it keeps values in a logical order. So sequential files keep values in a logical what? Store values in a logical order or in a sensible order. Now, how do we search for values from a sequential file? To search for values from a sequential file, we apply the serial search method, like the one we used in the serial file. How does that work? The computer will check all values beginning from the first value to see if the value that it wants is that value, or until when it reaches the end of the file without any value or without any match. So in this, the method used to search for values in the sequential file is the same method used to search for values in the what? In a serial file. However, for sequential files, since they are sorted in a logical order, the search might be quicker or easier. How? Because you can program the computer to begin from a certain what area without having to go from the beginning. But it depends on your programming. It is possible, yes, but sometimes it's not applied. If you want to apply it, you can apply it. Because you could tell that now, for example, if I'm searching for 7, I can tell that now 7 can't be inside where it's 5 and 6. But it's the same thing as comparing what? Each value to 7. However, we have what's called the binary search method. Binary search method is where you can divide these values into 2 groups. I'll teach you that how it works later. If you want to make the search quicker and you don't want to begin from the beginning, if you're using sequential files, you can divide this file into 2 and see which side 7 belongs. Is it this way or this way? We shall teach you that. I can just show you a sample how it works. For example, here if I have 5, 6, and 10, and I want to use the binary search, I don't want to search from the beginning. What I'll do, I'll go to the middle value, which is 6, the middle value in the list, which is 6. Then here I'll check If 7 is greater than 6, that means I will leave this side. I won't search that side. I will just go with these two new values, and the other ones I will search. Or I will search the values after 6, and the ones I will search and compare with 7. So these ones I won't use them anymore. Why? Because I've determined that 7 can't be this side, because the values are in ascending order. That is called the binary search, but I will show you the binary search later. For now, how to search for values from a sequential file, we use the serial access method. You search each value after value from the starting value until you find the value you want, or until you reach the end of the file without any match of value found. How do you update values in a sequential file? Now, a sequential file, remember, has to keep values in a logical order. For example, here, the values are supposed to be in ascending order, and you want to update 6. For example, and you want to make 615. What will happen here? It is very simple here. A new file will be created. After the new file is created, the computer will copy all the values from the old file, but it will make sure it will update the value that needs to be updated, and you will put it in the correct position where it's supposed to be. So the logic behind is that it will basically go to 6. When it goes to 6, it will increase 6 or update it the way it wants. For example, to 15. When it makes it 15, it will now insert all the values and make sure it puts 15 in the correct position. That is the order. But these are not asked so much in A2. Don't worry about sequential files so much. What they look at mainly is serial and random. Serial and random. So I think you've seen from what I've explained, in a sequential file, values must be sorted in a logical order. That is a must. That is a must. So whatever methods we use to input, we must make sure the order is maintained. But then, now, this is what they ask in your exams. How does a random file work? Now here, I want us to pay attention, and then so you can understand this. So how can we add these values to the random file? So I want to rephrase this question. Why? Because the random file, there's something it needs to use in order to calculate the position. Now, first of all, what is a random file? So I'm going to change this question because these values can't be put in a random file alone. There's some extra information that they need. So let me rephrase this question now. Give you a better view of how a random file works. So students Peter, Anne, and Dan need to keep their records in a random file. Their student IDs are 101, 102, and 108 respectively. Show how their records will be put in a random file. Show how their records will be inserted in a random. Now, here I want you to pay attention. Now, these are the details we need to put. Peter and Peter and Peter and Dan need to keep their records in a random file. Now, their student IDs are these ones. The reason why I talked about student IDs because with random files, we must use what we call the primary keys to calculate where the values are going to be. I'm going to show you why it is like that. Now, if this is our random file, here, if this is our random file, this random file has got different positions, 1, 2, 3. Let's assume it has got 10 positions. 1, 2, 3. This is our random file here. And this random file is supposed to keep maybe 10 values. 3, 4, 5, 6, 7. Shall we get 8 here? 8, 9, and 10. The file has got 10 positions. I need to keep records there. Now, how does a random file work? A random file is a file which can keep records in a scattered manner in any position. There is no specific position. You may find that Peter's record can be put in position 1 or position 10. And this record can be put in position 2 or any of these positions randomly. The records are stored in any random position. Records are kept randomly. They're kept, yes, Greg? Greg, I'm seeing your hand up.
No, it was a mistake.
Okay, fine. My Zoom has 10 minutes, I think you know. In case it gets over, just rejoin. But we are getting a new system in 2 weeks whereby the lessons won't end. We're going to be using Microsoft Teams. So for today, you have to bear. If it gets over, just rejoin. Nothing we can do. So here in random files, values are kept in any random position, any random position. For example, here, Peter's record can be put anywhere. There's no specific order. So now, how does the computer determine the random position where to put Peter's record? That's where the computer now comes and uses the student what? IDs or the primary key values, what we call the key values. It uses the primary key values to calculate the positions. How does it calculate the positions? It applies a formula to the position. That formula is called the hash algorithm. You get? Before I tell you technically what it is, all you need to know is that in a random file, to calculate the position where to put the records, we must use the primary key values and apply a formula to them. In this case, what formula can we use? The formulas are different. I'm going to do this. I'm going to say that if I get the key value, which is the primary key, and I get the mod of that value with the file size, then the answer I get will be the position. If I get the key value, if I get the mod of the key value and the file size, then I get the position. Remember, our file size in this case is 10. Even if the question didn't tell us, but I'm assuming it is what? It is 10. So here, to get the position where Peter should be, Peter's record should be, we shall get the key value of Peter. The key value of Peter is 101, then modulus 10, which is our file size. Now this one means 101 divided by 10, then remainder, and the remainder is 1. So the remainder becomes the position where now we shall put Peter's record. So Peter's record will be in position 1. We move to Anne. Anne's student ID is 102, which is the key value. So to get the position where Anne's record should be, we shall get 102 mod 10. 10 is our file size. The remainder will be 2. And that's where we shall put Anne's what? Anne's record. We move on to Dan. Dan's student ID is 108. So to get the position where we should put Dan, we shall get 108 modulus 10. This is the key value modulus the file size. This is one of the commonest formulas they use when they're dealing with random files, but there are very many, like you'll see. You can come up with your own. You get? So here, 108 mod 10 is 108 divided by 10. The remainder is what? Is 8. So which means now Danny's record should go in position what? 8. So now we shall put Danny's record there. I think you're seeing now. We are keeping the records randomly. However, in order to calculate the positions where the records should be, we are using the primary key values or the key values to calculate the positions. So what we are doing basically in computer science, what we are doing is this. To get the position where to put a record in a random file, we get the key value and we apply what we call a hash algorithm. A hash algorithm is a formula. We apply what we call a hash algorithm. The key value, which means just a formula like this. Key value modulus this. This now the formula. It's called the hash algorithm to give us the positions. So the positions that we get are the positions where the values are put, and those positions are referred to as hash keys. As hash what? As hash keys. This is just a technical word. Hash key just means the position in a random file, but that position is got after calculating after performing a formula to the key value in order to get the position. The formula is called the hash algorithm. So that's how we basically determine the positions where to put the values in the random file. However, sometimes there's a possibility that you might calculate a position which is already filled. You might calculate a position which is already filled. For example, here, let's assume a new student comes and a new student is called Ian or Ivan. And the primary key value of student ID of Ivan is 708. You see? So if Ivan's student ID is 708, in order for us to know where to put Ivan, we shall get the student ID, which is the key value, and then we perform a formula called the hash algorithm. This formula will be 708 modulus what? Modulus 10. This is the common hash algorithm, by the way, which even will come in your exams. This is what they use. They just get the key value divided by the size of the file, then the remainder is the position. So here, 708 mod 10 gives us what? 8. Because if you divide 708 by 10, you get, I think, 70, remainder 8. So now here, the position is 8. We have to put there Ivan's record, but 8 is already occupied with Danny's record. So what would the computer do? That situation is called clashing. Such a situation is called what? It's called clashing or collisions in a random file. Clashing or collisions. Because you have calculated the position where you want to put a record, but that position is already what? Occupied. And you can't put two values there. So what does the computer do in this case? There are very many solutions to clashing, but there are two major ones you need to know. The first one is to search for all empty positions, beginning from the one where the value was supposed to be. For example, here, after knowing that it's supposed to be in position 8, the computer now will move to position 9 and check, is 9 free or not? Then next, is 10 free or not? Is 1 free? Like that. It continues, it searches all the positions, see which one is free. It begins from the position that comes after the position where the value was supposed to be, to see which position is free. Then, for example, here it finds that 9 is free. So since 9 is free, it will put Ivan in position. Ivan is record in position what? In position 9. Since position 9 is what? Is free. So here it will put Ivan is record in position 9. That's what it will do. Then the second method is to create an extra free space. To create an extra free space. And then put all the records there that are causing clashing. So it means that on top of this file which is there, the computer can go and create an extra file and then to put Ivan there. It can create an extra file outside the normal file and then it can put Ivan's record there. So it means that then it have to put Ivan in position 9. That's also another what? Method of solving what? Clashing. But all in all, in random files, values are kept in any random positions, but to calculate the positions where to put records, the computer uses the primary key values of the records, what we call the key values, and then performs a formula called the hash algorithm, technically, that's how we call it in computer science. Then after performing that formula, the answer which is generated will be the position where to put the value. Now, this is the same thing it uses when searching for a value from a random file. For example, if you want to find the record of Dan, What the computer will do basically is to ask for the student ID number of Dan, and that is 108. When it finds the student number of Dan, it will get that student number, which is 108, basically, and perform a what? A hash algorithm, or perform that formula we talked about, which will be 108 modulus 10. In this case, I'm using 10 because I'm assuming our file is taking maximum 10 what? Records. But if the file was taking, for example, 100 records, then you shall modulus 100. You modulus with the file size. Then here it will get 8, which means now the computer will jump to 8 and to pick Danny's record. That is how random files work. I'm going to show you a second example. This Zoom is almost getting over. So when it restarts, I'm going to show you another example of how to use random files and this hash algorithms. So let me end it now quickly and I restart it, but we join immediately.